Hey everyone, let's jump right in and tackle one of those things in algebra that can look kind of tricky at first. Evaluating functions. I promise you, by the time we're done here, you'll see it's way easier than it looks. So you're looking at your homework and you see something like this. F of x equals 3x plus 1, and your brain just kind of goes, huh? If you've ever felt that way, trust me, you are not alone. It looks like a secret code, but it's really just a simple set of instructions. And the main instruction is that word, evaluate. It sounds so formal, right? But all it means is find the value. Seriously, that's it. It's just a fancy math name for substitution, something you've probably done a million times already. So here's our game plan for today. We're going to break down what evaluate really means. Then I'll let you in on my favorite trick, the parentheses power-up. After that, we'll run through some examples, I'll show you the common traps to look out for, and finally, we'll see where this stuff actually shows up in real life. All right, first up, let's turn that weird-looking math notation into a simple, straightforward action. Here's the whole deal in a nutshell. You get a rule, think of it like a recipe, and you get an input, that's your ingredient. All you have to do is follow the recipe with that one ingredient and get your final dish. One number goes in, and just one number comes out. Okay, now for what I think is the most important part of this whole process. This one little technique is a total game changer, and it will save you from so many headaches, especially when you start dealing with negative numbers. And here it is, the secret weapon. Before you plug in any numbers, the very first thing you should do is rewrite the entire function, but put empty parentheses wherever the variable is. This one step is your key to getting it right every time. And this shows you exactly what I mean. Look, we start with f of x equals 3x minus 5. But step 2, that's the magic. We rewrite it as f parentheses equals 3 parentheses minus 5. We've created these perfect little parking spots for our number. And only then, in step 3, do we drop our input, in this case the number 4, right into those spots. Okay, theory is one thing, but let's actually put this secret weapon to the test. Let's get into some real examples. Let's start off with a nice, straightforward one. We have our function, g of x equals negative 2x plus 7, and our job is to evaluate it when x is 4. So what do we do first? Parentheses. We rewrite it as g of 4 equals negative 2 times 4 plus 7. Now just follow the order of operations. Multiply first. Negative 2 times 4 gives you negative 8. Add the 7, and you get your final value, negative 1. See, an input of 4 gave us an output of negative 1. Done. All right, time to level up a bit. This is the kind of problem where our secret weapon goes from being just helpful to being absolutely essential. We've got a square term and a negative input. This is exactly where most mistakes are made. Let's walk through this carefully. We substitute negative 5, but we do it inside the parentheses. So we get h of negative 5 equals negative 5 squared minus 3 times negative 5. Now the most important part. Negative 5 squared means negative 5 times negative 5, which is a positive 25. Then, subtracting 3 times negative 5 is the same as subtracting negative 15. Which is really just adding 15. And 25 plus 15 gives us 40. The parentheses made sure we got it right. So let's really hammer home why this little parentheses trick is so powerful. It's because it's specifically designed to help you sidestep the most common and most frustrating traps in algebra. And here it is, the biggest trap of them all. Let me ask you, what's the difference between these two expressions? Because if you just type the first one into your calculator as you see it, it will probably lie to you. It might say the answer is negative 25, and that is not what we want here. And this is exactly why. Without parentheses, the calculator follows the order of operations very literally. It does the exponent first, so it squares the 5 to get 25, and then it applies the negative sign. But when you use parentheses, you're telling the calculator, hey, the thing I'm squaring is the entire number, negative 5. And that gives you the correct answer. Positive 25. The other big trap is just stopping halfway through. I see it all the time. Someone sets up the problem perfectly, but they just write down f of 4 equals 3 times 4 minus 5 and call it a day. That's not the answer. That's just the setup. Remember, the goal of evaluate is to get that one final simple number. You've got to finish the job. Okay, so I know what you might be thinking. This is fine for math class, but when will I ever use this? Well, the truth is, you're evaluating functions all the time. You just don't realize it. Let's pretend you're on a trip. This function, f of x equals 0.85x, is a simple rule to convert US dollars to euros. The input, x, is just the number of dollars you have. So if you want to know how many euros you can get for $100, you need to evaluate the function for f of 100. So how do we find out? We take our input, 100, and we plug it in. We get 0.85 times 100. And the output, the final value, is 85. Your 100 US dollars just became 85 euros. And here's the really cool part. This isn't just some abstract idea. A computer is running this exact type of calculation, a simple substitution into a function, every single time you swipe your credit card in a foreign country. And that's really what I want you to take away from this. We just looked at a function that converts money. But just think about it for a second. What other functions are running in the background of your life? Maybe there's a function that calculates your phone's battery life, or one that determines your commute time based on traffic. Once you start looking for them, you see these rules, these functions, are absolutely everywhere.